So continuing on from the previous video, let's take a look at how to find whether a sequence will converge or diverge. So in order to find whether a sequence will converge or diverge, we have to set the limit to infinity. The limit as n approaches infinity of the sequence a sub n. And so basically we're looking at n behavior, or the last term in the sequence. And so if it equals L, or some finite value, or known value, then the series will converge to that value. But if the limit as n approaches infinity of a sub n does not exist, or is plus or minus infinity, then that sequence will diverge. So for number one, let's find if a sub n equals n times n minus 1 will converge or diverge. So the first thing I'm going to do is actually simplify n times n minus 1 and just distribute that n. So we'll get n squared minus n. And then the next thing, obviously, I have to set the limit. So the limit as n approaches infinity of our sequence, so the limit as n approaches infinity of n squared minus n. So as mentioned before, similar to calculus 1, all we're doing is looking at n behavior. So notice how we have n to the first power and n squared. N to the first is basically insignificant compared to n squared. So we're basically just looking at the highest degree of the function. And so if we plug in infinity, infinity squared is going to be infinity. So the limit is infinity, which means that it will diverge. Now for number 2, we have a sub n equals 3 plus 5n squared over n plus n squared. So once again, I'm just going to set it equal to the limit. So the limit, or put it in limit notation, so the limit as n approaches infinity of our sequence, so 3 plus 5n squared over n plus n squared. So similar to the previous problem, once again, n behavior, we're just going to look at this significant terms, or the highest degree terms, on the numerator and the denominator. So on the numerator, the 3 is insignificant, so we're just looking at 5n squared. And then on the denominator, the n is insignificant compared to the n squared. So remember that whenever we have the same degree, it is just going to be the ratio of the coefficients. So the limit as n approaches infinity of 3 plus 5n squared over n plus n squared is going to be equal to 5 over 1, which is just going to be 5. So that's the value to which the sequence will converge to. So now let's say we have a sub n equals cosine of n over 2. So once again, limit notation. So the limit as n approaches infinity of our sequence, cosine of n over 2. So if I plug in infinity for n, then I'll get cosine of infinity over 2. And that 2 once again is insignificant, so we'll just get cosine of infinity. And remember, since cosine of infinity oscillates, or the graph of cosine oscillates, we can't tell the limit of cosine of infinity, which means it does not exist, which means that the limit or the sequence diverges. So for number 4, we have a sub n equals cosine squared of n over 2 to the n power. Now this might look a little bit confusing at first, but remember that cosine of x will oscillate between the y values of -1 and 1. So if I were to set up the limit notation once again, the limit as n approaches infinity of cosine squared n over 2 to the n. So once again, at most of the time, the graph of cosine will be equal to some y value between -1 and 1, which means that it will be a fraction. And so let's say we plug in a number like 1,000, a very large number. Cosine of 1,000 we know it's going to be somewhere between -1 and 1. And if we square that value between -1 and 1, we'll still get some number between -1 and 1. So let's just say we have 1 over 2 to the 1,000th power. Notice how this is going to be a very large number compared to the numerator. So if we have a bottom heavy fraction, then the limit as n approaches infinity, or a very large number, of cosine squared n over 2 to the n is going to converge to the value of 0. So for number 5, we have a sub n equals 1 plus 2 over n to the 1 over n power. And so I'm going to set the limit once again. Of our function here. Now this might look a bit complicated, but let's just try plugging in infinity. So if we do so, we'll get 1 plus 2 over infinity to the 1 over infinity power. Now 2 over infinity is just going to be 0, because 2 over a very large number just goes to 0. So we'll get 1 plus 0 to the 1 over infinity power. And 1 over infinity is the same thing like 2 over infinity. It's basically going to go to 0, because 1 over a very large number gets closer and closer to 0. So we'll get 1 plus 0, which is 1, to the 0th power. So the limit as n approaches infinity of 1 plus 2 over n to the 1 over n is going to be equal to 1 to the 0th power, and anything to the 0 power is 1. So it will converge to that value.